Hi everybody. We're going to start a unit on geometry, and we're going to split this lesson, this unit into three parts. So today we're looking at geometry section 1, which is questions 1 to 20. Let's have a look together. This is just the introductions. The questions are quite easy. As we go through the lesson, through the unit, the questions will get much more difficult. Question 1. Sam has a garden broken down into 3 plots, as shown below. The area of 2 of the plots are given in square feet, and the length of one side of each of 2 plots is given. What are we asked for? We're asked what is the total area of the garden in square feet. So this means we need to add together number 1, number 2, and number 3. We already know the area of this one, and we already know the area of this one. So we need to find out the area of number 3 first. This is going to be a triangle, so the area is half the base times the height. We know that this is 20 feet. So 400 divided by 20 gives us 20. So this means that this side here must be 20 square feet. That's useful because we're trying to find out, we know that this side is going to be 20, but we need to know what this side is. If we can find out what this side is, and then we can subtract this part of it, then we can find out what x is. So we have this one, area number 1 is 800. One of the sides is 20, so if we divide by 20, we find the missing length. 800 divided by 20 gives us 40. So we know that this whole length is 40. To find the area of the triangle, we need to find this area, this length x. So if we have 40 minus 20, which is the bottom part, we know that this top part is also going to be 20. So now we can put those into the formula. We have half times 20 times 20. So half times 20 is 10. 10 times 20 is 200. So the area of the whole of the garden is area 1 plus area 2 plus area 3, which means we have 800 plus 400 plus 200. So the area of the whole garden is 1,400 feet squared. In the exam, the feet squared would already be there for you, so you would just need to write 1,400. Staying with the same garden, if Sam wants to replace the perimeter fence, so the perimeter means we need to go all the way around. How many feet of fencing, which is sold in whole feet, will he need to buy? So this is going to be 20 and 20. We already know that this is 40. This also will be 20. This also will be 20. So we now need to find out what is x. We know that in a right angle triangle, which we can see this is going to be a right angle triangle, we know that a squared plus b squared equals, let's say, x squared. So this is going to be 20 squared plus 20 squared equals x squared. 20 squared is 400 plus another 400 equals x squared. So x is equal to the square root of 800, which gives us x is equal to 28.28. To find the total perimeter, we need to add all of the lengths together. Let's start here. 20 plus 20 will give us 40. Another 20 will give us 60. Add on the 40 and we get to 100. Add on the 20, we get to 120. And add on the 28.28, so we find the perimeter is 148 0.28. Now, if this was normal, if this was a normal question where we're rounding, we would say 148 is the answer because we would round down. But this is one of those questions where you're buying something. And because you can only buy in whole feet, you have to go up. If you only say 148, then you would have a small section that would have no fencing. And that's no good. You want to replace the fencing all the way around. So the perimeter, the fencing that we need to buy is 149 square feet. Yes, we'll have a little bit extra at the end, but that's the only way to buy enough to complete the whole of the perimeter. So the correct answer is answer A. Question 3. What happens to the length of C of the hypotenuse of the right angled triangle if the lengths A and B of the two legs are doubled? Okay. Now, I'm going to put in some very easy numbers for us of a triangle that we should already know. This is going to be A, this is going to be B, this is going to be C. We know that if this is 3 and this is 4, then this is 5. 3 squared is 9, plus 4 squared is 16, and the square root of 25 would give us 5. The question asks what happens if the two lengths of the legs are doubled. So let's try it out. This time we're going to have a length 6 and 8, and we want to know what happens to x. Well, 6 squared is 36, 8 squared is 64. And if we add these together, we get 100. The square root of 100 is 10. So if the lengths of both the legs are doubled, the hypotenuse also doubles. So you should have written down, it doubles. A question like that, some people might already know the answer, but when you're asked what happens if, well, it's the same when we see that kind of question in science. If, let's just draw it and try it out for ourselves and put in numbers that we already know so we can work it out in our heads. If we put 2 and 2, then we have to work in decimal places and we'd have to use a calculator. But by putting 3, 4, 5, we know these numbers are a right angled triangle, so we can double them very easily and work out the answer in our head. Question 4. What happens to the area of a right angled triangle if each side is doubled in length? So let's just use these two triangles that we've used before. 3, 4, and 5, and 6, 8, and 10. The area of a triangle is always half the base times the height. So on here, half the base times the height, half times 4 is 2, times 3 gives us an area of 6. Try it again on here. A half of 8, which is 4, times by 6 is 24. What's the relationship between 6 and 24? Well, it's increasing, not decreasing, so we can take away answers B and D. And 6 times by 4 is 24. So it is increasing by a factor of 4. So the correct answer is C. And again, it's one of those triangles, it's one of those questions, what happens if? So let's not try to guess, let's just do it and see what happens. Number 5. Andrea must paint an antique sign composed of 3 spheres, each of which has a diameter of 12 inches. Each can of paint covers 288 square inches. How many cans of paint does she need? So we have spheres, like a football. Now we need to know what is the surface area of a sphere. For surface area of a sphere, this will be included on the formula sheet. So if this was in your exam, right now you would look at the formula sheet. The surface area of a sphere is 4 pi r squared. What is the radius? Well, we know that the diameter is 12 and the radius is half of the diameter, so the radius equals 6. So let's work out the surface area of one sphere. This would be 4 times pi times 6 squared. Put that into your calculator. I don't know if you're using a good calculator or a bad one. If you're using it in the exam, you use the pi button. If you're doing it on your phone right now, you might be using 3.14. It doesn't tell you, so it doesn't really matter. But in this one, I'm going to use 3.14. If you get an answer that is slightly different, that's because you're using the pi function. So we put in 4 times 3.14 times 6 squared, which is 36. So the surface area of one sphere is 452.16. How many spheres do we have? Well, it says that there are 3 spheres. So we need to multiply this by 3. So just stick it into your calculator, times by 3, and you get the answer 1,356.48. So the surface area of all 3 spheres is 1,356.48 square inches. Now look at the question. 1 can of paint covers 288 square inches. We want to know how many cans of paint she needs to buy. So we take the total and we divide it by the 288. And that would give you the answer 4.71. If you wrote down 4.71, then you're going to be wrong because she's buying cans of paint. You know that when we paint something, we cannot buy 0.71 of a can. And if we buy less than what we need, something will not be painted. So that means we need to buy 5 cans of paint. So the correct answer was 5. Question 6. A square has 4 feet on a side. What is the area of the largest circle that fits within the square? So here is our square, and each side is 4 centimeters. The largest circle that we can draw inside of here will touch each of these sides. Yes, I know that's a very bad circle, but it is a circle. And the circle would have a diameter of 4. We are asked what is the area of the largest circle. So the area of a circle is pi r squared. If the diameter is going to be 4, then the radius will be 2. So this would equal pi times 2 squared. 2 squared is 4. 4 times 3.14 would be a little bit over 12. So the correct answer is going to be B. It would be 12.56 square feet. Question like this, draw a picture. If you draw a picture, it's going to help you to visualize what the question is asking you. And then that will help you to process that to find the information that you need. Now for the square in the problem above, so this is the square in the problem above, we've got the square which has a length of 4, and we have a circle which is touching all 4 sides. What is the area outside the circle but inside the square? So we're asked basically, what is the area of these corners? So we would say the area of the circle minus, so the area of the square minus the area of the circle. The area of the square is going to be 16. 4 squared is 16. The area of the circle, we know from the previous question, is 12.56. So if we subtract these, we get the answer 3.48. So the correct answer is 3.44 square feet. Again, in the exam, you don't need to write the units. That would already be written for you. So you would just write down 3.44. Question 8. A rectangle is 6 feet wide and it has a circle of a diameter 6 feet inside it. How high is the rectangle if the areas within the circle and outside the circle are equal? Let's draw this. It's a little bit more complicated. We have a rectangle, and the rectangle is 6 feet wide. And it's got a circle that is 6 feet in diameter inside of it. So this is 6 feet. And we're asked, how high is the rectangle? What do we know? Well, we know that the area of the circle is equal to the area of the rectangle minus the circle, because it says the area in the circle and outside the circle are equal. So the first thing we need to do is work out the area of the circle, which will be pi r squared. The radius will be 3 because the diameter is 6, so the radius is 3. So this is pi times 3 squared, which gives us the answer 28.26. Now, if the area inside the circle is equal to the area outside the circle, that means the area of the rectangle equals 2 times 28.26. So the area of the rectangle is 56.52. .52 will also be equal to 6x, because the area of a rectangle is always the length times the height. So to find out what x is, we need to divide 56.52 by 6. So if we divide that by 6, we get the answer 9.42, which is answer D. So the correct answer is D. Again, questions like this, take it steady, take it easy. Draw out what it's asking you, visualize what you have. You know that these questions will always be based on formulas that you are familiar with. So all you need to do is think about, what formulas do I know? How can I apply them to this drawing? And how can I find the information that is missing? Question number 9. Catherine is designing a HUD, like a cover for a barbecue. The top is to be 36 inches wide. So this is going to be 36 inches. And it will have the ends that are shown in this diagram. She wants to know how many inches of sheet metal will be needed for the HUD. So she's trying to find surface area. And you can see that actually in the answers, because these are all square inches. So we're dealing with surface area, not with volume. To find the surface area, we will need to know the surface area of this end times 2 for both ends, plus the back, plus the front, plus the top. We won't need the bottom because it's going to cover, so it's not going to have a bottom. So the top will be 24 times 36. The back will be 16 times 36. The front, we don't know how long this side is. Let's call it x for now. But we do know that we can make a right angle triangle. If we draw a line down here, we can make a nice right angle triangle. We know that this side is 16, and we can work out this side here. If the whole of the bottom is 30 inches and the top part is 24, 30 minus 24 gives us 6. So this part of the base is 6. So x will be the square root of 16 squared plus 6 squared. This is just a squared plus b squared gives us c squared. So 16 squared is 256. 6 squared is 36. So we add those together and we get 292. If you then square root 292, you get the answer 17.08. So the front is 0.088, so 0.09 times by 36. The end is a trapezium. To find the area of a trapezium, it's A plus B divided by 2 times by the height. So A is 24, B is 30, divided by 2. So 24 plus 30 gives us 54, divided by 2 equals 26. So the end will be 26 multiplied by 16. So now we know what we're doing, we can work out all these separate parts. So the top is going to be 24 times 36, which gives us 864. The back is going to be 16 times 36, which gives us 576. The front will be 17.09 multiplied by 36, which gives 615.24. And the end is 26 times 16, which is 416, but there are two ends. So because we have two ends, we then need to multiply that by 2. So we get 832. Finally, we need to add them all together. So we have the 832 plus the 615.24 plus the 576 plus the 864. So we get a total of 2,887. At this point, you see that I've made a small mistake. Now, sometimes in an exam, if you get to the end and you realize you've made a small mistake like this, you might be tempted just to guess the closest answer. But we're talking about a difference of almost 40 square inches. So it's not just with rounding. So here you might get a small difference. If you go to 2 decimal places or 1 decimal place, you will get a small difference. So now we need to go through and check everything again on the calculator. 24 times 36 is 864. 16 times 36 is 576. 17.09 times 36 is 615.24. 24 plus 30 divided by 2 is 27, not 26. Multiplied by 16 would then give you 864. So if you now add those together, you're going to get 2,919.24. Okay, this was 0.6, I get 0.24. That's because they've gone to 1 decimal place, I've gone to 2 decimal places. So the correct answer is C. I want you to learn from this. I could quite easily have just stopped the recording and gone back to the beginning and recorded it perfectly for you. But actually, you can learn. When you're doing an exam, it's very easy to make small mistakes, especially with the bits that are easy. The complicated part of working out the x, of working out the how to do this, applying the different formulas, all those bits I did correctly. Notice the bit that I did wrongly was the most easy part, 24 plus 30 divided by 2. And that's something that you can do in an exam. If you're working quickly, you can easily make a small mistake like that. So there's a couple of things I want you to remember. Number one, write down what you're doing. In the exam, you have whiteboards and marker pens. Write down the steps that you're following so that if you do make a mistake, you can go back and check each step carefully to find out where you've gone wrong. Secondly, don't just assume that you got everything right. At the end of the exam, if you have time, go back and check your working. Check the answers. Even if you think you got them right, if you have time at the end of the exam, don't just leave early. Go and check all of your work again. You'll be surprised. You might just pick up 1 mark or 2 mark extra if you find small things that you made mistakes on. So that's my advice to you. Write everything down and do check everything, because anybody can make a mistake, especially in an exam where you're under a lot of pressure. Questions 10 to 19, you're never going to see in an exam. However, they are very important. You should have this basic knowledge. Let's start with the sphere. This is a sphere, not a circle. And you know that because it says volume. When we talk about area, we're talking about the surface area. So the area is 4 pi r squared. We already used this in a previous question. And you should know that the volume of the sphere is calculated by 4 over 3 pi r cubed. So the volume is going to be E. Let's look at the cone next. The cone and the cylinder are very similar. They both have a circle on the bottom. So we're probably going to see pi r squared in some places. So let's look at h. H is pi r squared plus 2 pi r h. Well, 2 pi r squared would give us this, and pi r squared h would give it, sorry, pi r h, no pi r squared, pi r h would give us this. If we unravel a cylinder, what we end up with is a rectangle with 2 circles. So the 2 circles are found, the area of the 2 circles is found by saying pi r squared times 2. And this is 2 pi r, pi diameter, or 2 pi r, giving the circumference of the circle, and multiplying it by h. So the area of the cylinder will be answer h. How about the volume? Well, the volume will be pi r squared multiplied by h. So the volume is going to be answer C. The only other one that's got circles in it is the cone. So answer A, pi rl and pi r squared. This must be the surface area, because if we're only having a square, we're not going to have a volume. The volume will be 1/3 of pi r squared h. Pi r squared h is the same for the cylinder and the cone, but the cone, because it's missing out this part, is 1/3 of the volume of a cylinder. So F is going to be the volume of the cylinder, of the cone. So we've done A and B and C and D and F and H. Now, this one looks very easy. The cube, or sometimes they call it a rectangular prism. This volume is going to be LWH, the length times the width times the height. Doesn't matter which order you put them in, but length, width, height, this is going to give you the volume. So now H is done. I, we have half the base times the height times the length. So half the base times the height times the length. This will give us the volume. So I is going to be the volume of a triangular prism. What we have left is E and G. 2HL, 2HW, 2LW. So this one and this one and the back one and the top one and the bottom one. This is the surface area. G is going to be here. Now, this is a little bit confusing. Sometimes in the GED formula sheet, you see BH. BH means the base times the height, plus PL, and P is the perimeter of the base. So the perimeter means to go all the way around like this. For me, I would find this side, I would find the bottom, and I would find the back. There's 3 separate triangles. But you can add together this, and this, and this, and multiply by this. And that will also give you the length, the area of that piece that goes all the way around. Don't be confused. If you do see formulas in a slightly different way to what you're used to, you can just use the old formula that you might have learnt in Myanmar school, in migrant school. If you know the formula in a different format, it's fine. Different countries tend to write the formulas in different formats. And sometimes when you see me doing these videos, I will write the formula in a slightly different way. That's just because that's what I learned when I was at school. And even now, many years later, I still remember those old formulas. Last question. What is the difference between the amount of water that can be held by a sphere of a diameter of 1 centimeter and a cube with 1 centimeter on a side? So we're saying, what is the difference? When we see that word difference, we should be thinking minus. So we should be saying the volume of the sphere minus the volume of the cube. The volume of a sphere is 4 over 3 pi r cubed minus the volume of a cube. It is a cube, so it's 1 centimeter on each side, so it's going to be 1 cube. So the sphere has a diameter of 1, which means the radius is 0.5. So the volume of the sphere is 4 by 3 times 3.14, or times pi, times 0.5 cubed. So you can start, for me, if I was doing this on a calculator, which I'm going to do right now, I would put 0.5 times 0.5 times 0.5 to get my 1 cubed. Multiply that by 3.14, or multiply by pi. Multiply by 4, and then divide by 3, which gives us 0.523, and that's recurring. 1 cubed is 1 times 1 times 1, so that's 1. So actually we need to do this the other way around. The cube is going to be bigger than the sphere. So this will be 1 minus 0.523, which gives us the answer 0.477. Okay, that's the end of these first 20 questions. That's the introduction to the geometry unit. A lot of the questions will be much more difficult than this, but hopefully that's just refreshed your memory on some of the basic geometry concepts. We'll continue tomorrow in the second part of this unit. Osla Saikoda.